Ultimately, we design circuits to purposefully interact with electrical signals. Analog and digital. Analog, like voltage, is a continuous signal and has no discrete value. It can take on any value within its range. Some examples of this are current, temperature, light, and then so on and so forth. Digital is just the opposite. It's a discontinuous signal that can take only a finite amount of values within a finite range. An example of this is the temperature that's displayed on your digital thermometer. So why do we use analog at all? At one point in time, people thought that once the digital revolution started, that we were going to do away with analog circuits altogether. But we know now that this is impossible. Analog signals is everything we see, everything we hear, everything we feel. We are analog beings that live in an analog world. So ultimately, we need to build circuits that interface with these natural signals to be able to do some interesting processing and useful things later. Some common applications for analog circuits are processing of natural sounds, sensors, analog to digital converters that create the interfacing for digital communications, and microprocessors. So at the bottom of the slide is an example of how illustration of how an analog signal can be turned into a digital signal. The thing that is very disadvantageous of using an analog signal is that it's very susceptible to noise, which is just anything on the outside that can mess with the signal, essentially. So it makes it very inaccurate to be able to measure this signal. So even though analog signals are necessary, digital signals are far more accurate and easier to deal with, which allows them to have a much wider reach for their applications in modern day technology. A digital signal can be stored, transmitted, and reproduced exactly the same as an original. And the biggest thing that makes digital so much better to use in processing than analog is that it's not susceptible whatsoever to noise. Most consumer electronics use digital electronics for processing. Here are just some common examples of analog circuits. We're going to show you an example of the 555 timer, how it's used, and how you can build a pretty cool circuit at home using some very simple components. Here are some very common digital circuit examples. Microprocessors, microcontrollers, and here at the bottom is an integrated circuit called a 4017 decade counter. And we're going to go into more detail on how these work and how you can use one at home yourself.